Is my screen is visible? Can you please anyone confirm that my screen is visible? Okay, fine, thank you. So this is the first session of your course. Okay, so this is an interactive session. Okay, so let me start it on a full screen. Before starting this conversation, I just want to mention that actually you all have to gone through already. I think the first week lectures that was provided in the NPTEL portal. Okay, so this session is mostly we have to discuss some of the questions related to the first week, and that will help you to make you understand the uh, theory part as well as you can able to solve the assignment one. Okay, so anything related to doubt, any questions which I'm going to solve, you can raise your hands, you can ask. Okay, so you already have known that the course instructor is Professor Ramakrishna Patsumarthi, okay, from IIT Madras. So I'm a TA for this course. My name is Viswajit Sahu. I'm a research scholar at IIT Bombay. Okay, so before starting, just I want to review of the week one what was already told. That was in the lecture. Okay, so already actually in the first introduction of system and control is already discussed in the week one lectures. So various types of systems are classified, like which are causal system, which are non-causal system. First of all, what is a system? Okay, then sub classification of various system. Similarly, linear, nonlinear system, time invariant, time variant system, static and dynamic system. Okay, so uh, exit means all other systems are there. Like you can say that's invertible, non-invertible system. Okay, so lots of categorization of the system have been done in the course. So we're going to solve some of the questions related to this part. Also, let me add someone who is actually with the waiting list. It's hard. So then we'll go to the mathematical modeling of the system. Okay. So mathematical modeling of the system, what was described in your first week was related to how we can model a system. Like on what equations we are going to use to model that equation, like differential equation, transform, transfer function, that model. Okay. Then state space model. So these are the three uh, forms which are already we are simultaneously learned by step, but how to model a mathematical model by using differential equation that has already been discussed in the week one, that I'll discuss some of the problems, and also how a mechanical system is and a rotational system is analogous in force voltage domain or force current domain. That also we are going to see some of the questions. Okay, so some people are joining. Okay. So any doubt regarding this course or structure, means any doubt, you just please ask before we start moving to the next part. Any doubt? Any doubt? Or shall I move on? Okay, I'm going to solve some of the questions that is related to assignments, which will help you to solve your assignment. So let me go to the first question. Okay. So in the first question is related to system. Okay. So various types of system what was discussed. So some of the questions I have framed here. So these are the two questions: y of t equal to x of minus t square and y of t equal to cos t. Now you have to say that whether the system is causal or not causal. So first of all, what the system is causal? A causal system is something which present output depends on present input as well as the past input, but it doesn't depend on the future. If it would depend on the future, then it is called a non-causal system. Then, so for the first question, your y of t equal to x of minus t square. Okay, can anybody tell me for which value of y if the system depends on any future value? Can anyone please respond?
So it depends solely on present value.
Right, I'm saying that you have to check it that for what value of t you have to put in time such that your present output depends on any future instant. If that is not, then it is a causal system. If it is depends on any future value, then it's a non-causal system. So if I'm saying that, let's say I'm putting t equal to 1. If I put t equal to 1, then I derive 1 equal to x of minus 1. Okay. So it means your present output 1, it depends on that x of minus 1 value, which is a past value in time. Okay. This is a past value in time. That's why you can say that this is a causal system. But you don't interfere as long as putting only one value. You have to take multiple value. Suppose I am putting, let's say for example, if you put t equal to minus 0.5, then what will happen? Y of minus 0.5 is equal to x of how much? There is a minus sign and this is minus 0.5 square. Okay. So what is this value? This should be x of minus 0.25. Okay. It means for minus 0.5, for x equal to minus 0.5, your this value, okay, this is for y, okay, for x equal to minus 0.5, this present value depends on this x equal to minus 0.25, and for x equal to minus 0.5, okay, this is 0, this is your minus 0.25, and this is your minus 0.5. So this for this value, it depends on the future value, minus 0.25. So it means this value depends on the future value. So that's why for x equal to minus 0.5, the system is not a causal system. It means the overall system, you can say it is a non-causal system. Once you get one value of input for which your present output depends on your future input, then it is a non-causal system. Everyone is clear?
Yes, sir.
Okay. Similarly, you can solve by yourself y of t equal to cos t. So can
Sir,
any,
please could you explain one thing?
shall I explain one more time?
Yes, sir, yes, sir. Sir,
Okay.
your audio is also not clear, sir. Some disturbance is coming on it.
My audio is not clear to you or all of you. Can you please confirm?
Sir, once again, please
I think
explain
from
question
your
number
back,
one.
yeah. But sir, please confirm me that actually my audio is clear or not.
Yes, sir, it is
Audio
clear,
is
but
clear, sir.
Okay, fine. So let me explain it again. So first of all, what you do, what is the question? There is a question that actually there are two questions. So first of all, take the first question. This is the bit A, and this is the question is given to you. Okay, this is the question is given to you. Y of t equal to x of minus t square. So they are asking you to verify that whatever the system is given, this is an algebraic equation. For this equation, tell me that if this is a system, okay, this is your system or whatever plant you can say, you are applying some input, okay, and you are producing some output, okay. y of t. Input is suppose let's say x of t, where output is let's say y of t. So now, so there is an equation that is governing the system, and that equation is this one: y of t equal to x of minus t square. So for that equation, they are asking you that you have to verify that whether it is a causal system or non-causal system. So first, what is the definition of causal system? Causal system means any system which present output depends on the present input as well as the past input. Then that is called a causal system. If at any point of time your present output depends on any future value, okay, then that is a non-causal system. So you have to verify that for what value of t, whatever the output you are getting, that depends on your present input as well as the past input. So I have checked two values. Let's say I have checked for t equal to 1. So I have taken t equal to 1. If you put t equal to 1 in that equation, you will get y of 1 equal to x of minus 1. It means I am putting t equal to 1. Let's assume that t equal to 1 is your present input. Okay. So at one point you are standing now. Now if you look at the response in the input, that input depends on a value which is a past input. Okay. It means you are at this position 1, but it depends on some value which is at minus 1. So it depends on the past. Okay. So it depends on the past. So fine. So you don't go to the inference that it is a causal system. Now you have to put another value of t. For all the value of t, you have to check. For any value is not satisfying, it is a non-causal system. So for this value, it depends on the past. So I am assuming that let's say for one moment of time, it is a causal system. But as soon as I put t equal to minus 0.5, now you put t equal to minus 0.5 in that equation. So it will be y to the power minus 0.5. So y to the minus 0.5, what is the equation is now? X of minus is there. T square means minus 0.5 square. That will be minus 0.25, right? So x of minus 0.25. So what value you have taken at present? You have taken a present value here. This is the present value. Okay. Now, at what instant you are getting your input? Your input you are getting at something valued minus 0.25, this value. So for minus 0.5, this minus 0.25 is a future value. So that's why you conclude that whenever I put y equal to minus 0.5, my present output depends on a value which depends on the future input. That's why you conclude that it is a non-causal system. As this point is clear.
Yes, sir. Thank you.
Okay. So
Okay,
now,
sir. Okay.
similarly, you just try to solve y of t equal to cos of t. Now you can see cos of t. Okay, I am just making a slide here, blank slide. Okay, so y of t equal to cos of t. Okay, let me write down this.
It's non-causal.
Y of t equal to, let's say, x of cos t. Okay. So can you tell me for what value we are putting at t such that you are saying that it is a non-causal system?
Sir, if t is equal to 0, cos 0 is 1, no, sir. So it
Okay,
is
let's put.
depending upon the future value.
Okay, 1 minute. So you are saying that if you put t equal to 0, then your y of 0 equal to x of cos 0 is 1. It means if you put at 1, then you depends on a future value. So you are concluding that it is a non-causal system. You are absolutely correct. Okay. Everyone clear this point? This is the B part B.
Yes, sir.
Now I'm just giving one questions. Okay. Let someone else wants to join the meeting. Uh, Let me give a question. Let's say I'm putting for you y of n. Okay. Let's say you can say that x of minus n square. Then can you please solve this question? Y of n equal to x of minus n square, and tell me whether it is a causal system or non-causal system. Are you able to
Sir,
follow
this
me?
is a similar question, sir.
Yeah.
Yeah. This is a similar question, sir. You have just put n instead of t. It should be non-causal.
You are saying that it is a signal question means
Same question, sir. Same question. Similar.
okay. Now just verify it whether it is a causal system or non-causal system. That's why I'm giving this question. Okay. So don't be, and if you are saying that it is a non-causal, then you have to tell me at what value of input you are getting a future value. Can you that confirm this? So don't blindly say that it is a non-causal system. I'm giving this question means you have to tell me that for what value of input you're getting a future output. Okay, like that. Okay, so you tell me that value. Let's say I'm starting with n equal to 1. If suppose one module puts n equal to 1, then you get y of 1 equal to x of
It's non-causal, sir.
minus 1. Okay, so it means for 1 it depends on the past value, so for this it depends on the past. Then any other value, if I put y equal to 0, okay, then what do you get? X of minus 3, this will be 0. It means again it depends on the present value. Now can who is telling that it is non-causal, can you please confirm that for what value you are getting a future input? This is for n equal to 0. Now for your clarification, if you put n equal to minus 1,
Negative value if you take, then it will come. So
okay, let me put it negative value y of minus 1, then what is this value? What is this value?
X of minus 1.
Again it depends on what value? Present value.
Sir, may I take the discrete values?
Yeah,
Decimal values like 0.25.
this is a discrete system. Okay,
Okay,
so
okay, discrete system. Okay, okay, okay. Yes, yes.
it's a discrete system. You have to take a discrete values, not decimal values. So now because in front of you my screen is saying three values, I have taken one value from 0 above, one value 0, another value from 0 back. Okay, so I'm taking all the values from, you can say, minus infinity to infinity. You can put any discrete values, so the result will be like this: one depends on past, other two are dependent on present. So this system is a causal system. Clear? Are you clear? This is not a continuous time domain system, it is a discrete system.
Sir, whenever we take minus 2, then it will be minus 4.
When you take n equal to minus 2, so it depends on y of minus 2 will be x of minus 2 square is minus 4, sir. So minus 2 you are taking, it depends on minus 4, it is a past value. Are you
Okay, sir.
getting?
Okay, thank you.
Okay. Still, it depends, it's a causal system. And this part will help you actually to solve actually which are causal system, which are non-causal system. Okay. So don't blindly take just info. So take some values, and one value take from present, one value take from past, one value take from future, and put that value in a system and check at which point it depends on what. Okay, so so this part is clarify that the system is causal or non causal. Okay, so you can similar type of question you can solve by yourself. Okay, and that will help you to solve your assignment. Okay, so let me go to my next question. That's question number 2. Okay, so it is a system that's saying that whether the system is linear or not. Okay. So this question number 2 is the system. You have to tell that whether it is a linear system or it is a non-linear system. Okay. So now what you do, first of all, you need to know that how a system will be linear and when a system will be non-linear. Okay. So first of all, let's go to the linear system. Linear system means everyone you know that the system, if a straight line is there, if a linear it's called, it means it has to be passing through a horizon. Okay, so if we saying that y and this your x, okay, so it means your y equal to some m times of x. this is a graph which is showing that passing to the origin for every value of x, we are getting a corresponding value. So this system is linear, okay. So, but when you're coming to control system or like modeling of any system, like signal system, so in that case, linearity is defined by two things. Okay, so two principles is there. So one is called superposition principle that is already been described by the profession. Okay, superposition principle. It has to obey the superposition principle, and second is it has to obey the additivity theorem. Okay, superposition, and this is called additivity, and superposition another is homogeneity. Okay, so what are these? What are the things? Okay, that is already been described in the lecture. So based on that, just I'm giving a glimpse of hint what is the superposition and what is an additivity. So suppose a system is called x of t, okay, and it gives its output response y of t. Then what is the superposition theorem? Let's you take one input, okay. That input I am saying that x1t. So if for x1t you are getting an output, let's say y1t. See, another person, what do you do? No. I'll take another input, let's say x2t, which is different from x1t. And for that corresponding output, he is getting y2t. So if you apply superposition, means if you add these two systems, x1t plus x2t, if another person is coming, he is saying that, let assume that after addition, this input is called my x3. Okay. So x3 is now equal to x1t plus x2t. That will gives an output y3, okay, and this y3 is equal to the addition of these two, y1t plus y2t. Then this is called your superposition principle. Okay, similarly, what do you mean by this is called superposition? Like you have solved many network questions based on superposition principle. Okay, so means the total response is nothing but the summation of the individual response. This is the case. Okay, now second one is the added means like homogeneity. So this is a homogeneity principle. Let's say one x of t is giving my output y of t. Okay, then what is homogeneity is saying that if I scale this value x of t is by a constant, then the corresponding output also scaled by that factor. Okay, it means our output also multiplied by y. If that is happening, then it is called the homogeneity principle. If you combine both, if you combine both means homogeneity and superposition, if both the condition will be satisfied, I'm writing the equation for that. So suppose I'm incorporating this homogeneity into the superposition. Let's say I'm multiplying a value a, then the corresponding output will be a. If I'm multiplying a value b, then the corresponding output will be b. It means my x3 is now equal to ax1 plus bx2. Okay, it means my y3, it has to be ay1 plus by2. If this condition is satisfied, okay, last equation means I'm incorporating both your superposition and homogeneity. If this condition is satisfied, then it is called a linear system. All of you please understand how I will going to approach a question. Are you
Yes,
following
sir.
that? Okay.
Yes, sir.
So now let's solve the first question. Okay. So try to solve this first question here. So let me solve from the bottom side. Okay. That will clarify your ideas. How? Let me solve y of t equal to mx plus c. It's a basic question. You know everyone. Y equal to mx plus c. Okay. Then can how can I approach this question? Okay. Let one person will subdivide. He will apply here superposition theorem. Okay, and other person will start with, no, I will start with homogeneity. So you can start with anyone, but you can also combine both, But let's say I start with the individual superposition and homogeneity differently. So first of all, what you do when you are applying a input x1, what your y1 should be mx1 plus c, right? It is clear. When I am applying x1 input, your y1 should be mx1 plus c, because wherever x1 is there, you just change that. Similarly, another person will apply input x2. Your output should be y2. That should be mx2 plus c. Yes or no? Are you following, guys?
Yes, sir.
Yes,
Now
sir.
you combine. What I'm saying, you just combine. Combine means you are applying now a input x1 plus x2. What I Let's say this input is x3. Okay, you are just applying the summation of x1 plus x2. Now your output y3. This should be. Now tell me what I'm doing here. Whenever we're applying input x1, you are applying input x1. You are just replacing this equation by x1. Similarly, just do that. Okay. Whenever your y3 is there, your equation should be m times of, in place of x, you have to put x1 plus x2. Okay. And plus c. So now you solve just open this bracket mx1 plus mx2 plus c. But is should be equal to the summation of output. Okay, summation of output equal to y1 plus y2. Okay, summation of output should be equal to y1 plus y2. But what is y1? Y1 is your mx1 plus c, and your y2 equal to mx2 plus c. But whenever you apply x3, this is your output. But this output is not equal to your y1 plus y2. So this value, two values are different. These two values are different. So you are saying that the superposition principle is not applicable. It means it violates superposition principle. That's why as it violates superposition principle, it is a non-linear system. Are you following?
Yes, sir.
Okay. So no need to check homogeneity, okay? Because superposition principle is not violating. So right why if one person is going to also superposition, let me say how we are going to apply superposition here. Let's say x1 is giving you y1 mx plus c. Okay, you're applying x. Now you just multiply a constant here ax. Okay, then your outputs will be m, in place of x what you are applying ax. Okay, so write down that. So solve this equation. This will be m ax plus c, and that should be equal to your scale version. Okay, scale version means you're multiplying. What you're multiplying here, go to the previous slide. So it means axt equal to ayt. Okay, so it means your ayt means what? Y is mx plus c. So I'm just changing my pen to confirm. So this is equal to y is mx plus c. You have to multiply a. So that should be equal to amx plus ac. Okay. So these two, this one and these two are not equal. So it is also not satisfying homogeneity principle. So definitely you can say that it is a non-linear system. I think you guys are clear that how can you check by using superposition and homogeneity principle. Clear? Any doubt? Any doubt? If any,
No, sir.
okay, if you're not having any doubt, then you please go to the next question and solve by yourself. Okay? Just tell me the answer. Okay. So the next question you just start with just bit C. Okay. Y of t equal to tx up. Y of t equal to tx up. Y of t equal to tx up. Can anyone please confirm that whether it is a linear system or non-linear system? How you approach? Let's say you are applying some input x1. So for that x1, you are said that
Superposition is verified, sir.
superposition is verified. So both you have to verify, not one. Okay, maybe sometimes your superposition is valid, but the homogeneity is not valid. So at that time you are saying that it is non-linear. So both has to be valid. Okay. So let me do for you. At x1 I'm applying. So whether that is how the output will be t times of wherever x is there, you just write down x1. Okay. Similarly, whenever another person t I'm not writing for simplicity. Okay, you can understand that why I'm not writing t. So this y2 equal to similarly tx2. Now I'm combining, okay, both superposition and homogeneity. Okay, so how I'll do that? Just said that you have to multiply a here and multiply b here. Okay, so I'm just writing that on the below line. Okay, let's say ax1 plus bx2. Simultaneously I'm applying. Let's say this is my input, another input x3. So that will give me another output y3. So t, wherever x is there, you have to replace that term x3. Okay. So what is x3? ax1 plus ax1 plus bx2. Okay. Now you simplify this. When you simplify this, it will be t times of ax1 plus t times of bx2. Is this output whatever you are getting that is equal to whenever you are applying x3, this output? So this has to be equal to your ay1 plus py2. So what is ay1? Ay1 is this one. So a times of tx1, b times of tx2. So if you simplify it, it will give you tx1 plus tpx2. It means now you can check your outputs in both the cases. Okay, in both the cases they are same. So I'm applying both superposition and homogeneity in one line. So both are same. So you can say that this is a linear system. Are you following?
Yes, sir.
One more question you just do by yourself now, and after that, then this question you can solve later. So let's say solve the first question. Y of t equal to sine x of t. Okay, sine of x of t. Okay, so y of t equal to,
It's non-linear.
yeah, y of t. Let me check it out. Y of t equal to sine of x of t. This like this. This question is like this. So what you do like that? Whenever I apply x1, your y1 equal to sine wherever x of t is there, just put x1. Okay, sine of x1. Similarly for x2, you are getting y2, which is sine x2. Okay. Now apply both simultaneously. ax1 plus bx2. This is nothing but your x3. With that will give a response which is sine of, okay? Wherever x is there, you just replace this x3, and x3 is nothing but this value. So ax1 plus bx2, okay? And sine of something, if you, this value is same as ay1 plus by2. So ay1 is sine x1 plus b sine x2. So now you can clearly see that this output 1, and this is your output 2 are not equal. Okay, 1 is not equal to 2, so that's why it is a non-linear system. Everyone clear?
Yes, sir.
Sir, please could you explain once again?
This slide.
This slide only. Can't we apply sin A plus B formula there, sir?
So sine a plus b is not equal to a is you can apply sine a plus b. Then sine a plus b formula is sine a into cos b plus cos a into sine b, which is not equal to this value, right, sir?
Okay, sir. Okay. Got it, sir. Got it.
Sine a plus
Just 1
b,
minute, sir, so that I will
yeah,
copy
sine,
that slide.
right, sine a plus b is something sine a into cos b plus cos a into sine b. So that is not matching your output to. Shall I move?
Okay, sir. Okay. Thank you.
Okay. So I think this is question number 2 is over. Question number 1 is over. Question number, okay. This part is question number. Similarly, you can verify yourself x of cos t. Okay. So the same approach you have to follow. Let me make this slide here. Question number 3. Okay. So question number 3 is another type of classification of the system, that is whether a system is time invariant system or time variant system. Okay. So one or two examples I have taken here. So first of all, you have to understand that what is a time invariant system. So time invariant system means whatever you are doing that doesn't depend on something time. Okay. So that is called time invariant. Something you are doing that is not depend on your time. Okay. Suppose I'm present, I'm doing something, I'm teaching. It doesn't depend on that what instant of time I'm doing. Okay. So let me in mathematical term, if you want to solve this type of question, then what you are expecting that whatever the delay that is happening in the input, let's say x of t is there and is giving y of t. If I'm delay my input, okay, x of t, let's say I'm delay by some amount t0. Okay, this is your delay time. Then your output also delayed by that value. Okay. It doesn't depend on the time. Okay, it doesn't depend on the coefficient of time. Whatever you are shifting one equation to the right amount, some amount, then your output also displaced by same amount. Okay, it doesn't depend on the time, it depends on the value which is added both same value. Okay, so this you can say in mathematical analysis. So let me solve the first question for you. Let's say I am taking y of t equal to x t square x of t. Okay, this is t square times of x. Now what you do, you have to delay your input by some amount, and you see that your output also delayed by the same amount. So first you delay your input. What is your input? Your x of t. What is your delay time? Let's say t equal to 2 seconds. I want a 2-second delay in my input. So what you do here x of t minus 2. I'm delaying the system. Delay or advance. Okay, same thing. You are delaying something input means your output also delayed. If you want to advance your input means your output also advance. Okay, so like that you understand. So x of t minus 2. So what is your output you will give? You're delaying your input x of t minus 2. So what is your output now? This implies your y of t is now, you're delaying your input. Wherever input is there, x of t. So now x of t equal to t minus 2. Okay. But what is your output? Your output is means, I'm just changing my pen. You just try to understand. Y of t minus 2. This is your output because you're delaying your output by same amount. So that means wherever in output is this equation. Okay. But I'm changing in my t. How much? T minus 2. So you have to put wherever t is there, you have to put t minus 2. So that will be t minus 2 times of x of t minus 2. Now you are delaying only your input. This value is output. Let's say answer 1 and this is your answer 2 when you are changing your output. So answer 1 and answer 2 are not equal. Okay. That's why you can say that it is a time variant system. It is not a time invariant system. It depends on time. So this system is a time variant system, not a time invariant system. I think everyone is clear.
Yes, sir.
Okay. The second question, can you tell me x of 2t, whether it is a time variant or time invariant system? Solve
Time
by
invariant systems.
the second one. You are saying x of 2t.
Time invariant systems.
Okay. I just want others let you
Yes, sir. Time variant system.
time variant. Okay, two different opinion is coming. X of 2t. Okay, just writing for you. Y of t equal to x of 2t. So suppose this question is coming in some gate exam, competitive exam. You can one step you have to check your answer. Okay, I'm just scaling the first time input. I'm changing first one, writing the answer. Y of t equal to just only change in the input. Some even 2 second delay, right? So this will be. I'm just changing my input. That input is just same input is just going 2 seconds forward. Okay, and change your output. Output is y of t minus 2 and that should be equal to x of 2 times. So wherever t is there, you just write down t minus 2. Now you have to simplify it. This will be x of 2t minus 4. So this is 1, this is 2. So 1 is not equal to 2. So it is a time variant system. All of you clear? All of you clear this?
Yes, sir.
Okay, I'm just giving on simplifying.
Sir.
Yes, hello.
So in first case, since y of t is x of 2t,
Hmm.
in first case you have changed the input, no, sir.
Yeah, I'm just changing the input.
Okay, okay. Since it is 2t, we should not write it is 2 into 2t minus t naught, no, sir.
No, no,
That
no.
is the
You can
doubt I
write
got.
whatever x of t is there, just delay that value. Means whether x of cos t, suppose the x of cos t is there, then what you have to delay? X of cos t minus 2. Okay, not x of cos t minus 2.
Okay, 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 sir.
Okay, so only change in that value. Suppose have you because you have come across this thing linear time invariant system, okay? Because control system, remember that all the systems should be LTI system. Whenever a system is linear time invariant system, then you are able to solve that equation by using transfer function approach. Suppose in any case you are getting a system which is linear time variant system, you can't able to solve that question, or you can't able to find out the output response by input excitation, means the transfer function, by applying that transfer function method. Okay, so in that case you have to apply state space model upfront. So whenever you are dealing with any control system, remember that if a system is linear time invariant, then you are able to solve the transfer function approach the output by input. Otherwise, you can't solve it. So for that, because have you seen that d square x by dt square something dx by dt, okay? So plus let's say 5x equal to 0. This is simple. You have come across this type of equation. This is definitely linear time invariant system. Okay, it's a LTI system. Okay, so now you apply your concept. First of all, you apply here linear principle. Then you apply time invariant principle. Then you can confirm that okay, it's satisfying all. So it means whether a differentiation definitely it is a linearity. Okay, definitely it is a time invariant. Higher order differentiation d square x by dt square, also it is a linear time invariant system. Okay, so means your whatever your output, if this type of format will be there, then any type of question is there, you just apply this type of principle and verify by yourself that whether the system is LTI system or not. Okay. So let me go to the second method. Okay, second means mathematical system modeling. Okay, because in your assignment these are some questions are there. Okay, so how to solve this type of questions? Okay, so before going to that, mechanical system, whenever you are going to model a mechanical system, it will electrical equivalent. Okay, so a mechanical system, first of all, you have to understand that what are the things in the mechanical system. The first thing in the mechanical system is your mass. Okay? The second thing, okay, so before actually coming to this lecture, you have to go through the lectures video so that you can able to understand. Okay, I cannot teach everything here. Just I'm giving a hint. So first one is mass. Second one, you can see here there is some spring are there. Okay? Third thing, in sometimes a mechanical system, damper is there. Okay, damper, or you can say this is called dashpot. Okay, so mainly you are coming across these three types of system into someone wants to join. So mainly mechanical system is represented by these three terms. Okay, so how you are going to model a mechanical system? Okay, how to find out the difference equation or the differential form of the equation from a mechanical system. So that you need to, we are now going to solve some of the question. So before coming to this question, just I'm giving one more question to you guys. You just because you have already let me duplicate one slide here. Just deleting this one. So have you all of you gone through that mechanical system modeling part? Have you gone through how to solve that question? Please give me an answer.
Yes, sir.
I think those people who want to join here, just please join at 6 o'clock. Okay. Otherwise, I'm coming back again, moving forward. So it's disturbing for me. So please join at exact time. Otherwise, so let me give an question. It's questions for you. This is a very famous type of questions. Okay, if you're able to solve this question, then I think you are capable of solving all the questions. Okay, so let me. There are two masses are there. Okay, these are the two mass. Let's say this is my mass M1 and another mass I'm taking. This is a physics type of problem. Okay, so this mass is having a wheel. Okay, so this mass is also s- sitting over the wheel, and in between the mass there is a dashpot. Okay, so this is the dashpot symbol. Dashpot is nothing but is called frictional. Okay, frictional coefficient, because this is mainly stores its energy in the form of viscous. Viscous means either you have air or fluid. Okay, so this is called viscous friction coefficient. So this dashpot also it having a spring. Spring is generally represented by this. Okay. So let's say this viscous friction coefficient is B, and this K is having an elastic coefficient K. Okay. So now, and this frame is also tied to the reference rigid frame. This is a reference. Okay. This is a type of system, and this is rising here. Let's say its value is K1. Now you're applying some force here. Okay. Somebody has applied a force F of t. Now, because of this F of t, in the question it is given that this M1, M2 is having a displacement of x, and this M1 is having a displacement of, let's say, x. There are two displacement because of the applied force. Now, this mass is rolling over this surface, so it having a another friction coefficient is, let's say, V1, and this wheel also with respect to this rigid surface is having a friction coefficient is B2. Now, I'm asking you what to find out. What to find out? First question is that you have to write the differential equation, okay, and then find the transfer function. Transfer function, how to solve? By using differential equation, you have to convert the differential equation into Laplace transformation, because your week 2 is mainly based on the Laplace transformation. So first of all, you have to convert this differential equation by Laplace transformation, and then what is transfer function? Transfer function is nothing but an output divided by input. What is my output? You are applying. What is your output now here? You are applying some force. You are giving some force. From that force, you are generating some displacement x. Okay. So this displacement is your output. So now x divided by f is just staying in terms of time. X of t divided by f of t. This is a transfer function. In Laplace domain, it will be x of s divided by your f of s. This you need to find out. This is a question. So, how to solve this type of question? Any mathematical question, any mechanical system which is having three main important things. So, what are the three important things here? First one is mass. Okay, here is m1 and m2. Okay. Second is spring. Here is there are two springs are there. One is K1, which is attached to the rigid body. Another spring which is attached between the two masses. So here is K1 and K. And another is your dashboard. Okay. So how many dashboards are there? One is connected between the two body M1 and M2. Okay, B. Another two are connected to the wheel between the ground. Okay. So one is B1, another is B2. So mainly These are your what? These are your parameters. So based on these parameters, you have to write the differential equation. So how to write the differential equation? The differential equation will depend upon the number of displacement. So whenever you are applying a force F of t, your mass m2 is moving towards the right side by an x amount. Our mass m1 is now moving towards the right by x1 amount. Okay. So first of all, to solve this approach, you have to draw the free body diagram of both the masses. And remember that this type of equation you are going to solve by applying superposition theorem. Superposition theorem means the individual response on mass m1 and the individual response on mass m2 you calculate separately and you just add it. Okay. So how do I solve this equation? So to solve this equation, first of all you draw the free body diagram. Okay. So free body diagram of both the body. Okay, how many bodies are there and how many displacements are there? Two bodies are there, mass m1 and here mass m. So here some displacement is x1 and here the m2 having a displacement of x. Okay, so individual you have to consider. So now till now everyone clear what is the question and how we are going to approach it now? Everyone clear the question?
Yes, sir.
Okay. If I able to understand the question, now the next step is that you have to draw the free body diagram of individual masses. Okay. So I'm just starting with the left side. Okay. So left side, I'll do. Let me draw here. So this is the free body diagram of mass m1. Okay. So here is the rigid body which is attached with the spring k1, and here there is a displacement due to this m1 is x1. Go back. Now you see when the body m1 is moving right side because of the force f of t. Okay, but f of t force I'm not applying m1, I am applying f of t force, means that external force to the body m2, not m1. So it means for m1 the external force is 0. So that thing you need to first clarify. So for m1 the external force f of t equal to 0. F of t is the external force which I am applying only body M2, not M1. So that's why for M1 the external force is 0. Now, but there is a displacement because these two bodies are attached. Because of a spring, another is a dashboard, it is attached. So I am moving, dragging one, so automatically the other having a displacement, supported displacement, you can say. I'm not applying any force on that, but it is moving. So So first of all, what is your first thing you need to identify what are the external force. Here the external force for the body M1 is 0, but there is a displacement x1. So because of that, suppose now my body is moving to the right. So always you apply Newton's law, okay? So whenever a body in the steady state condition, it always wanted to be in steady state condition. That is called inertia of rest. It means you are now dragging my M1 to the right hand side because of the nature of M1, it has to generate one opposing force which tries to avoid that means displacement. So because of that, you just write three things here. Mass, because of mass M1, there is a force will be generated, that is mass into acceleration. So M1, what is the acceleration? Acceleration is x1 is the displacement, so acceleration should be d square x1 by dt square. So this force, because of mass m1, is going to oppose this movement. So if your movement is on the right hand side, this force, I'm saying this is due to mass m1. So this is the opposite direction, f of m. Another thing, one spring is there. Okay. So because of spring is having, okay, elasticity energy. Okay. So some potential energy is there. It wanted to be, if you want to stretch spring, Okay, it wanted to back to its normal position. So this spring is now, because of that force on the M1, M2, it is moving a displacement x1. Okay, but that force, my spring I always wanted to be come to the nature, okay, original position. So one force will be acting opposite direction of that spring. And how the spring, because of the spring, one force is acting that is directly proportional to your displacement. Okay, F equal to k times of x. So k is nothing but your k1, and the displacement is your x1. So this is the force that is applying in the negative direction. This is due to, I am saying, f of k. So this force is f of k. That is opposite direction. Another is the dashpot. So let's say it is f of b. Now you see where is that force. That force is this force. You can say that when this body is moving here right hand side, this frictional force is trying to oppose. This is due to relative motion. Okay. So this frictional force arises to relative motion, and that is opposite to the applied direction. So because your movement is x1 the right hand side, so your frictional force should act in the opposite direction, okay, of x1. So f of, and that is b1. So you write down f of b1, and that force, okay, frictional force is directly proportional to your velocity. So what is the velocity? This is a b times of, okay, this is a frictional coefficient b times of, what is the dashpot name? B1. Okay, so b1 into velocity is nothing but your dx1 by dt. Okay, but can anybody tell me, apart from these three, is there any other forces appearing on m1 in this diagram?
Yes.
Yes.
B. B
B
and
is
K.
right, because this B and K also attach between M1 and M2. When this, whenever I'm considering M1, okay, now I'm individually I'm considering M1 and M2 separately, the free body diagram. So I told you that you apply superposition theorem. So M1 you consider separately, M2 you consider separately. So now when I'm M1 is considering, so now we can see on the right hand side one dashpot is there, and that dashpot is now having a displacement depends upon the relative displacement of x1 and x2, because that dashpot is connected between m1 and m2. M1 is also moving, m2 is also moving, so that relative displacement is now coming into picture. So now one more frictional force, or one more, you can say, dashpot frictional force is appearing here. Let me call it is f of b, and that f of b is nothing but, this force is depends on your velocity. So it means this force into d by dt of displacement is how much. Now whenever you're considering your left side body, so always the relative position will be x1 minus x. Okay, so now you can write here x1 minus x. This is a relative position or relative displacement, you can say. Similarly, another force is there, that is due to k. So f of k, okay, that is also depends on the relative position because it is attached to the b1 and b2. So now write down that equation. It depends upon k times of x1 minus x. So these are all the forces which are going to apply in the negative direction. F of b, f of b1, and f of k. So all these forces are applying in the negative direction, that is opposite to your displacement. So you know that sum of all the forces is equal to 0. So what you do, you just write down the equation here, m1 d square x1 by dt square, I'm taking x double t because double t means the differential equation. Now plus here k1 x1 plus b1, here this will be x1 dot, similarly plus write down b times of x1 dot minus x dot plus, and this spring k times of x1 dot minus x equal to 0. So this equation is the first table diagram equation, equation number 1. Is everyone is clear?
Sir,
Yeah.
with K, sir, x1 dot, it should not be, sir, x1 dot, as I understand, sir.
Yeah, yeah,
The
you are right.
last,
You are right, right. Because it doesn't depend on it. It's just a displacement, right? You are right.
okay.
Thank you. So equation one is clear to all of you.
Yes.
Yes, sir.
Now go to the second free body diagram. Similarly, you draw the free body diagram equation for M2. Okay. So I'm just completing one slide here. Yeah. For M2, now this is your M2. Now, first thing what you need to carefully observe, what are the external force? Yes, there is an external force. And because of that external force, there is a displacement x. Now you know that there is a frictional force is also there. What is the frictional force? Is B2. Okay, so this is B2, and it is attached to one dashboard B, and here is K. So these are the equations. Okay. Now first you write down on the right hand side what are the opposing force. Okay. So what are the opposing force? It should be acting in the opposite direction. So first of all, you consider that whenever you are moving that body mass M2 to the right hand side, it doesn't want, because of inertia of raised, you wanted to come to the original position. So for mass M2, so there is a force Fm2, that is mass into acceleration M2 times of d square x divided by dt square. And because of this B2, this is Fb2, there is a frictional force B2 times of d by dt of x. Okay. Now, because of this dashboard, which is in the left hand side, I am writing f of b, which is now nothing but your b times of d by dt of x minus x1. Okay. And similarly for f of k, it will be k times of x minus x1. Any other force is there? I don't think so. There are only four forces in the opposite direction. So you can write the differential equation now. Sum of all the forces equal to 0 means my left hand side force equal to right hand side force. So I'm writing my left hand side force m2 x double dot plus b2 x dot. Why I'm solving this question? Because another interesting question is there on the next slide. Okay, that's why I'm just giving a flavor of how to solve this question. So here is b. This is x dot minus x1 dot plus k times of x minus x1, which is nothing but your f of t. This is my second differential equation. I think everyone is clear.
Yes, sir.
Now, find out the transfer function. What you need to do, guys, you just convert this differential equation into Laplace domain and solve equation and 1 and 2 and put this x1 in terms of x, and then you find out x by f of s. Okay. So that part I'm just giving a task to you. So, but my intention is that this is a overall mm, like mechanical system that gives you how to approach a question. But I have just given one question for you guys. So uh, let me solve this question. Now, can you anybody tell me what is the answer of that in one step? Okay, this is a one-line answer. Two springs are connected in parallel. The equivalent spring constant K equivalent. So what is the node here? There is a node. Node means there is a displacement force is there F. And from that node, there are two springs which are connected to your reference. Let's my reference here. So one spring is connected like this. Another spring is connected like this. K1, K2. Okay. So you know that when you convert into force voltage analogy, your spring constant will be replaced by your inductance term. So now K1 will be replaced by some inductance, and here this is another inductance. This is the common ground. Now there is some node. Now you see that. So how can you solve that? What is the resultant spring? Yeah, the spring constant K equivalent. How much? This will be
K1 K2 by K1 plus K2.
K1 K2 divided by K1 plus.
K2.
I don't think so, because your spring stores, right? Yeah, sorry. Your spring is storing. If you have a do a force voltage analogy, can anyone tell me that your mass will be replaced by which quantity, your B will be replaced by which quantity, and your K will be replaced by which quantity? Can anyone tell me?
Force voltage analogy.
Yeah, this is force voltage analogy I'm
So
saying,
mass is replaced by inductance.
right? And your B will be replaced by
1
Sorry.
by C.
a resistor, because this is a spring, let's say
Yes.
something, yeah. And your K will be replaced by 1 by C, right?
Yes. Yes.
So now your K will be something which is replaced by your capacitance. And you remember that when two capacitance in parallel, that should be added, right?
Added. Yes, sir.
So that's why your spring equivalent will be the K1 plus K2, not equal to your K1, and they are not series, okay? So don't be confused. So the answer will be K1 plus K2. Now, let me go to that question which I wanted to solve. Okay. This is the question. This one is one important question, because question number 5, please read the question. Question number 5 is similar question. Okay. Consider the system given below. What is the force balance equation at displacement node X? He is asking us to find out a differential equation at node X. Okay. And second question, question number 6, which is related to the question, the same question. We have to find out the transfer function between X and F. Okay. And question number 7 also related to the same question. Uh, Here I am saying that, okay, applying force voltage analogy, you have to write at node X what is the differential equation. Okay, these are the three questions which are interrelated. So now, can anybody tell me what is the difference between this question and the question which I solved earlier? Here there are two bodies, M1 and M2, and for both the bodies, there is a displacement x and there is a displacement x1. But now you look at this question. I am applying some force which is tied to the mass m. There is a displacement x, but there is another displacement, but nothing is there. There is no mass. So whenever this type of question is coming into picture, how you solve this type of question? For accurate answer, can anyone tell me how we are going to approach this x1 point? Because there is no mass here. This there is no mass. Mass is not zero, it's not visible to me. Also, it is not visible to you because it is not there in the question. So how I able to write the free body diagram? So first solve the question number 5. 5 is that you have to draw the free body diagram at node X. So go to node X. So this part is a node X. Okay. So just draw that mass A first. There is an external force F of t on the right hand side, and there is a displacement X on the right hand side. And here he is not giving us the frictional coefficient. It is not given. So assume that it is B equal to 0. This is not given in the question. So to this body, what are the external forces means which are opposing this? Can anybody tell me? Oh yeah, definitely there is spring is connected, K2, and before that nothing is there. Can anybody tell me how to solve this type of question?
So f of t is equal to mx double dot plus k2 into x.
At node x you are saying. Yeah, please tell me. M
F
double
of
dot,
m double dot
I write,
plus k2 into
plus k2 into
x minus x1
x minus x1. This
is
equal to,
equal to f of t.
I think everyone should be agree with this equation because this equation is correct. If anybody is having any doubt that why, because there is no bodies there, okay. So in this type of question, remember that whenever there is a displacement, okay, on the left hand side, and there is nothing is there, you just assume that there is a mass and that mass equal to zero. Assume that this there is a m, and because of that m, this k2 is connected between a two body. One is a virtual mass, which is value is zero. Another is a physical mass having a mass m. So that's why you assume that this k2 is connected between two body and having this mass is zero. So now this is the differential equation. I think everyone is clear. The first equation, right? This is the free body diagram at mass m. Similarly, you have to write the equation, the free body diagram at mass m equal to zero. So now can anybody tell me what is the equation here? Because there is a mass,
So k1 into x1
this mass is zero. So it should be k1 because this is connected to the fixed body. So it is having a displacement of x1. So k1 times of x1, right?
plus
Plus
k2 into
there is
x1
another
minus
body
x.
k2. So k2 times of, you are referring to which node? You are
X,
referring to this node. So this would be x1 minus x. The relative position would be x1 minus x to 0. Because there is no applied force to the virtual body. So that's why this is the two differential equation. Everyone clear this question? I think question number 5 is clear. Now come to next question, that is find out the transfer function. Can you solve this two equation? I'm just writing this two equation. Next to this, okay. Just I'm writing this two differential equation here. M x double dot. Here this one. Okay. So plus 8 times of x minus x1 equal to f of t is the first equation. Okay. Then it will be k1 x1 plus k2 x1 minus x equal to 0. So taking the Laplace transformation of the first one, okay. So it will be m times of s square times of x of s plus k2 x of s minus x1s, which is equal to f of s. Okay. Similarly, the second equation Laplace transformation will be k1 x1s plus k x1s minus x of s equal to 0. Now here in this in the second equation, I'm just taking x1 is common. Okay. So when x1s will be taken common, so it will be okay, k1 plus k2, and that is going to the right hand side. This will be k2 times of x of s. So from this you need to find out what is your x1 is. K2 divided by k1 plus k2 into x of s. Okay. Now just put this x1s in equation number. Just I'm giving you equation number 1. This is 2, this is 3, and this is 4. So putting this x1x value in equation number 3, then all the terms will be in terms of x's and f's. So you can find out the transfer function, I think. I think it's clear.
Yes, sir.
Yes. Now, if this question number 6 is over, I think everyone is clear. Okay, this is a very simple analogy to solve the questions. Okay, so now let's we go to question number 7. What is the analogous balance equation corresponding to displacement x obtained in question number 5? Okay, so this is also a simple question. So after applying the force voltage analogy, what is the analogous balance equation corresponding to displacement node x? So already for node x, the equation 1 is there. Okay. So whenever mass is there, you have to replace the mass. Okay. Uh, what is the mass will be replaced by inductance, right? And the spring K2 will be replaced by 1 by C2. Okay. And wherever x is there, x displacement will be replaced by what? Can anyone tell me?
Charge.
Right, charge. And wherever force is there, that will be replaced by a voltage. So that will gives you your force voltage analogy. Okay. So this type of question also you can able to solve. Okay. Now come to question number 8. Okay. So this question number 8, just this is just a why I have taken this question, because this is a question need to just practice the what is that is called your network analysis. Okay. So what is the question is giving to you? The question is giving to you that for the electrical circuit shown in the figure below, okay, find the equation which model the voltage across inductor. Nice. Voltage across inductor it is asking. So you need to find out, just find the equation which model the voltage across inductor, means you need to find out your VLT in terms of, okay, in terms of known parameters. So how to solve this question? You need to apply a KCL at loop 1, another KCL at loop 2, and you need to find out the voltage across inductor. So let me write the KCL for 1. So you can write. So how, because this is a simple approach, okay? Whenever writing a KCL, just follow the convention very carefully. So how I have taken the convention, either you choose 1. Whenever you are moving from minus to plus, either you take the negative terminal or you take the positive terminal. Like that, you just try to understand what is that. Write that equation. I am writing minus V of t. Why? Because I have chosen this fast point. Similarly, when current is flowing through any passive element, the voltage polarity always plus minus. So you have to choose the first point. First point is positive. Okay. So write positive. So this will be I1t into R1. So next, whenever this current is flowing here, what is this current here? This current is I1, this is I2, so this will be I1 minus I2, which is flowing through this resistor in this direction. So the first point is positive, second point is negative, because current is always in a positive element, flow from positive to negative. That's I'm writing here again, plus current is I1 minus I2, and that should be multiplied with R. And next, again, you have to consider the first point, because the first convention you are choosing always like that. So this will be VC T equal to 0. This is the first equation in case C, loop 1. All of you clear? Solve this, minus V of T plus I1 here and I1 here. Take I1 common. So it will be R1 plus R minus I2 R2 plus VC T equal to 0. Okay. Wherever I1 is there, I just write I1 T. Okay. For simplicity, I'm not writing. This is also I2 T.
So this is the Kirchhoff's voltage law.
Yeah, sorry, this is K. Yeah, it's a basic question. So this is KV. Okay. I'm so sorry. So this is the first equation. Similarly, you have to write the second equation in okay. So KVL2. So now you follow the same convention. Okay, the current is flowing. I'm just showing the here. So it means in the passive element like inductor, it will flow from positive to negative. So take the first point. So VLT. Now this loop is this will be complete like this. Okay. So the current is moving here. In a capacitor, it should be positive and negative here. So what is the voltage equation here? VCT is positive, but VCT polarity is given plus minus like that. So accordingly, you have to change. Okay. So VCT is given plus here, minus here. Okay. But when my current is flowing in the right loop, you have to this plus is here, minus is here. So opposite convention. That's why this is one is negative. Now here the same here again. The current will be how much? I1 minus I2 is the current, but you are moving in the opposite direction. That's why this equation should be negative. That is equal to 0. Either you choose KVL2, otherwise I will choose a loop equation which is this one. This is very easy. The third equation, if you want to write KVL3, so it will be over the system. Okay, so it will be minus V of T plus R1 I1T. Okay, you started here, you reached here, then you move here. Okay, so this is simple VFT. This is equal to 0. This is equation number 3. This is equation number 2. So if you solve equation 1 and equation 3, then your answer will be there. No need to find out KVL 2. This will be critical a little bit. But anyway, out of these 3, you need to solve and find out the voltage VLT. I think these equations are clear to all of you, right? If I am doing any mistake, then please be clarified. But I think they are correct. I think this any doubt still any in this questions 8 what I solved here, the 9 or 10 questions I solved, any doubt regarding all these 10 questions? Otherwise, I'll just add one more thing here before concluding this today's class. If you don't have any doubt, then I'll just explain one concept to you guys.
So can you go back to question 4?
Question 4. This one.
Uh, Here you have taken force voltage, but he hasn't. Uh, there is also possibility that you can take force current, no sir. Why you are taking only force voltage? If I consider force current, then the spring is
Yeah, spring is.
1/L, no sir.
Yeah. 1 by L, same thing. Now, one way to
Ah,
solve
okay, okay. You
that.
mean
Okay. In both the cases, actually, see, force current and force voltage analogy is same. Okay, only you are in which way you are seeing the equations, but the resultant system will not change. Okay, similarly in rotational system, these are all translational system examples. In rotational system also, the same thing, mass will be replaced by inertia. All these things are same. Force voltage analogy, force current analogy are same. So these are not different. Just
okay?
only the
Now I got a doubt. Since it is force voltage, we got capacitor. You have added K1, K2, no sir.
right, right.
If it is force current, if it is inductor, then again it will be
1 by L, 1
K1,
by
K2.
yeah. Have you clarified by yourself? That's good. Okay. So, so let me ask you one question. Okay. So, what do you mean by a static system, and what do you mean by dynamic system? Because that one system I actually think forgot to solve in question. So, can anybody tell me what do you mean by static system and what do you mean by dynamic system?
Basically, with memory, with
Yeah.
dynamic.
Right, sir. So, okay, can you sir please explain me that how one system I'm giving example? Can you give me an example of a system? Let's say, sir, in analog system, flip flop are there. So flip flop are the elements which are storing some energy, or storage elements, you can say. Your DVD, your CD box, okay, your pen drive, anything that is they're having a storing element is there. Whenever there is a storing element is there in a system, like you can say. Uh, like your inductor capacitor in a system, they're storing energy. Whenever that thing is coming into picture, that gives you a dynamic system. Okay, so exactly in definition, dynamic system is a system which is having a storage element. Then what is the meaning of a static element, sir? What do you mean by static system?
Sir, in static system, the output
Yeah.
depends upon the present value of input. Only the present value of input in
Okay, it
static
doesn't
system.
depend on the past, it also doesn't depend on the future.
Future,
Okay.
yes.
Okay. So one question, ma'am. Like suppose your causal system are the subset of your static system, or your static system is subset of your causal system.
A static system can be causal system.
Static system can be a causal system.
Yes.
Yes. See, means all the causal system. Are you saying that all the static system are by default causal system, right?
Yes, sir. Yes, yes.
Right. But the reverse is not true, ma'am.
Oh, okay.
Why? Because so a causal system it also depends on the past, right? So, but your static system doesn't depend on the past; it depends on the only present value. Means,
Yes, sir.
suppose you can predict my future, or you can predict anybody's future. Astrologers, these are things which are depends on the past input. The present value, we're predicting something. Okay, India will win the next match, or who will be the president of US, Prime Minister of India. These are all predictions. So it means is something you are predicting now. At present, I am predicting some future values. So, so these type of systems are not static system or not causal systems. Causal means it depends on only present and past. Static means it depends on only present. Got you, ma'am?
Okay, okay, sir.
Ah,
Okay.
okay. So anything, any other type of things you need to ask me, because I think most, it is 80-90% part I cover from week one. Okay. So if anything, having any doubt in week one, if you have watched the lectures before solving, because the assignment deadline is I think 31st, I think so. So you need to submit the assignment. So next week, I think mostly we'll go to move towards the control systems, because we have to deal with the Laplace transformation. Then how to solve Laplace transformation in MATLAB also. So that are the things I think in week, next week lectures. Already that is released in your portal. You can watch that. And the doubt clearing session also in the next week. This time we'll solve it based on some questions. Uh,
Sir, small request, sir.
right, sir. Yeah.
Sir, you are taking from 6 to 8 and another TA is also taking from 7 to 9. Both are overlapping. Please, could you
Uh,
adjust the
I
time?
actually, sir, I don't know regarding. I'll talk to the NPTEL team that actually how they have divided this time. I don't know because my slot is actually from 6 to 8. I have already saw that one slot is also going on from 7 to 9. I think they have given this slot because of the flexibility of the audience. You can join in anywhere because I think most of the thing are already covered in the lecture pattern. And what we are dealing here that actually based on the assignment, whatever the assignment question is given. So we are seeing that assignment and we are framing some question that you can able to solve your assignment and you can submit before deadline. So that is the purpose of this lecture or this tutorial. So also if you have any doubt also we can clarify this session. If I don't have an hour about the doubts, I will clarify in the next class also. But it's better to ask questions and you have an interactive session. Not only from my side, I'll solve every question, but your side also some inputs are there, our responses will be there, so that we can simultaneously solve the questions. That is a process of interactive learning. So, so if you have any doubt, any query, then you can let me know. I will just consult with the NPTEL team and I'll be back to you next week. So this doubt I have taken note. I have noted that in how many I don't know. So I'll just let you know next time. I'll ask them. Yeah, yeah, Guru Mohan, can you please, yeah,
Sir, sir, you are giving the URL of this video immediately, or it will take time, sir?
yeah, I have recorded. I will upload in my YouTube channel. Also, I will upload in that weekly log sheet what they have given. You can access it. Okay, no problem.
Okay, okay. Please give that
Means
link also, sir.
yeah, means today is 29 by 30 means by tomorrow morning also I'll upload it. No problem.
Okay, sir. Okay, thank you.
Okay.
So that we will watch once again, sir.
Yes, sure.
Sir, one
Yes,
small note.
yes, sir.
Sir, while verifying whether a given system is linear or not,
Right,
uh, if instead of giving some y of t is equal to 2x plus c something, if he gives in differential mode, that is suppose d square y by dt square plus 5 into dy by dt,
right, right.
in that model, can you explain one such model, sir? Whether how
Yes,
can
sure,
we
sure. Let me see. your question is that let's say your y of t equal to d by dt of x of t. Okay, is this one you are asking, sir?
So can I say the question, sir?
Yeah, yes,
Equation
yeah,
d square y by dt square
yeah.
plus 5 into dy by dt plus 10 is equal to x of t.
Okay, it is opposite. I just wrote y of t in terms of x, right? You are saying x in terms of y, right?
Yes, sir.
Okay. This is nothing because what you do, the same approach you have to take. Okay, whenever you have to check both your principle of superposition and another is your principle of that is homogeneity. So I have taken one input x1t. Then whenever you take x1t, your y1t should be wherever x1t is there, you just replace that. So it will be d square by dt square x1t plus 5 dx1 by dt plus 10. Right, sir? Are you getting this?
Yes, sir.
Now you just simply you have to put x to t. It should be y to t and this equal to d square by dt square x to t plus 5 times of dx2 by dt plus 10, right?
Yes, sir.
Now you put x3 and what I told you x3 is nothing but the addition of x1t and x2t. So x3 is nothing but the addition of x1 and x2. So wherever now this becomes y3t is equal to wherever x is there means the first equation, this you have to replace by x1 plus x2. So this will be x1 plus x2. This will be 5 times of d by dt of x1 plus x2 plus 10, right? You understand these three questions?
Yes, sir.
And you just open it. The last equation you just open it because d square by dt square x1 plus x2 is nothing but individually you can write it as d square by dt square x1 plus d square by dt square x2, right? Similarly here you can write 5 d by dt of x1 plus okay plus 5 d by dt of x2 plus 10, right? This is the equation, sir.
Yes, sir.
Now I can see, I can, if you add this two on the right hand side, means just I'm changing my pen to confirm you. These are the right hand side equations, 1 and 2. If you add these two, you are getting this term is similar to this term. This term is similar to this term. Sorry, this term, okay? And this term is similar to this term. This term is similar to this term. But here if you add this 10 plus 10 is 20, right, sir? But
Yes, sir.
your
Yes, sir.
output is 10. So definitely it is not satisfying your superposition theorem. But if this equation, it is a nonlinear system, but if this equation in place of 10, if you write it as x, okay, so then definitely it is a LTI system, I can say. Means it is a linear system. Remember that whenever sir you are adding some constant to any system, that definitely is a nonlinear system. Whatever the system is, like y equal to mx, y equal to mx is a linear system, but whenever you're adding c, a constant term, that makes a nonlinear system. Whenever a constant you are adding any system, that makes a nonlinear system. So that's why this is the case. In place of this 10, what you told earlier, if I write x, then that is makes me linear. That constant addition will make the system nonlinear. I think your doubt is clear.
Okay, sir. Thank you, sir.
Any other doubts or anything from your side
Clear.
wanted to know? Similarly, integration also, sir, like a differential equation, when you write integration of the system, that is also make the system linear, but don't add any constant value. I think if you don't have any doubt, then I think we'll wind up this session for today.
Thank you, sir, for so nice and valuable session.
Okay, thank you, welcome, sir.
Thank you, sir.
Thank you, thank you. If you no doubt, you can leave. And uh,
Sir, is there any a shortcut method to find the linear, non-linear? Because when you solve the problems, no, by superposition and homogeneity, it takes the time.
no, sir, actually,
But
we don't take time because actually you just integrate both. In one equation, you
okay,
just see. Because if you practice 10 more 15 questions, then you no need to apply homogeneity and superposition differently. You just combine ax1 plus ax2 directly, you see. Because when you see, you can able to see that, okay, my input is not, it will be not the output sum. So it will take
yes,
hardly, sir, maximum 10-15 seconds to judge a question. This is actually where there is no shortcut, sir, for this. Certainly, whatever thing you have to go by this way. If you practice 100 questions, then you might be very smart. Okay, cleverly you can say that, okay, this is linear and non-linear. So I
yes,
mean, like I'm saying, the incremental systems, like when adding constant, that make the system non-linear. So e to the power t terms. Suppose x equal to e to the power t. That is a linear system or non-linear system. So that you can verify. Some type of questions like diode equation, id equal to I0 e to the power v divided eta pt something. That's a
yes, yes.
non-linear system, non-linear equation. So when you solve 100 questions, then you can able to judge, okay, these things are non-linear, these things are linear. Otherwise, sir, this method is there. It would take time, at least 10-15 seconds more, but your accuracy will be good. You should not be mistaken.
Okay, sir.
Better
Thank
to
you.
cross verify, right, sir?
Sir, please could you explain about the analogy? I didn't get it, sir.
Okay. Which analogy? Sorry.
Parallel spring operation and that force. If it is converted as force current, then how to solve, sir? You have given 1 by c as k.
Yeah,
Then if it is the current analogy, then how to get it the answer?
I think this is the question, right?
Yes, sir. Yes, sir. Yes, yes.
So now actually here in force current analogy, actually what you did, whenever force voltage analogy, you are replacing this are the things, right? In force current analogy, your mass will be, just tell me what the mass will be, 1 by c.
Okay, sir. Okay.
And you just tell me, confirm me, mass equal to 1 by c, right? Your spring equal to how much? No, your mass should be, just tell me, because you have watched the video. Your mass will be replaced by, just give me that analogy, I'll tell you.
Act-
Otherwise, what you do, if you are confused now, I don't want to solve
Yes,
for
yes.
you just because why you are confused, because you have not watched the video. Okay, so better what you did, just I'm saying, just you just solve by yourself. Okay, how?
Okay, sir.
Just
Okay.
give me an example. Let me see how the approach. Let me delete this for you. See, generally mechanical system is represented by this. This is your rigid body. This is your mass M. This is your spring K. This is your some B, and this is your displacement X. This is a mechanical system, and this mechanical system is equivalent to a voltage source A R, L, and C. Right? This is voltage. This is
Okay, okay.
RLC. Now you write a voltage equation KVL here, and you know that what is the equation here? F of t equal to all the opposing forces. Opposing forces is mass into acceleration plus b into dx by dt. It means b into x plus your spring into kx. Right? This is the equation, right, sir?
Yes, sir. Yes, yes, sir. Yes.
And this is your v equal to IR plus L di by dt. Or if you write yes, v equal to L di by dt plus and Vc equal to 1 by C I dt, sir, right?
Yes, sir. Yes.
And if you do Laplace transformation, this will be f of x equal to how much, sir? M into s square x of s, right? Plus b into s x of s plus k times of x of s, right, sir?
Yes, sir. Yes.
And here this will be b of s equal to I of s into r of s. R is not, sorry, r is a constant. So I of s into r plus ls into I of s plus 1 by c integration of dt. So this will be I of 1 by c into I of s by s.
Yes,
Integration
yes,
is
sir.
right, sir.
Yes, sir. Yes.
So here you, in terms of charge, if you want to replace, because q equal to I dt, right, sir? Or I
Okay.
equal to dq by dt, right?
Are
So
Krishu?
dq equal to I dt, sir, right? Right, sir? Are you getting my point?
Yes, sir.
So now this I dt integration you just replace by dq. So similarly, you just compare these two equations and the coefficients. Okay, this is in force voltage analogy, sir. Got my point?
Okay, sir. Okay.
So in current force analogy, just write another equation. What is this equation? RLC are parallel, right, sir? This is voltage. This current is I1. This is I2. This is I3. So summation of voltage here is 0. Here summation of current will be 0. You write a KCL equation. Now you compare the force voltage analogy, force current analogy. Got my
Got the
point?
point, sir. Okay, okay.
Okay, just try, sir.
Depending on the mechanical system, we have to go for either voltage force
Voltage,
analogy or
yeah, currents, yeah. Yes, sir. The equations are different now. You see, the voltage RLC circuit in series, but whenever applying force current analogy, all the three terms are in parallel. The This is just a comparison, sir. How mechanical system will be represented in force voltage in KVL equation, force current in KCL equation. That's it.
okay, sir. Okay, sir. Right. Thank you.
Okay, sir. Okay, thank you so much. I think everyone is. I think I need to stop my presentation.